things off then. Welcome to session number 5, week number 3. Time is flying. We are getting through these things so quickly. So today's name of the game here is going to be a lot more about talking about loops that we've been doing before here. And we're going to be doing a couple other things as well, just to make your processing life a little more interesting, namely getting some inputs going in here. So let me go and get started with some inputs. And so I'm just going to go and double check something. Right, we are recording as usual. That's good to know. So with inputs here, basically, you guys are all familiar with the mouse press function here. Remember how you guys type in inside the draw section, if mouse press, capital P there, then you get to do stuff wherever you are clicking down on. Well, that's fantastic and all, but how about your keyboard? What do you want to do when you wanted to go and try getting keys instead? We have a way to go and detect if any button on your keyboard is pressed, and that's called key pressed. Now let's get that shown off right here. So let's ignore that. From processing import star def setup size colon 500 def draw, and then I'm just going to go background. I'm just going to use some of our regular stuff here. I'm going to type in run. Inside the draw section, we can also say if key pressed is equal to true. So remember, that's double equal, capital T, and a good old-fashioned colon at the end of the line here. We can go and print that key was pressed. And hopefully this should be no surprise to anybody, but when we're running this code here, I can just go and mash any key. You guys can't see me pressing here, but I'm pressing A, S, D, F, G, H, K, blah, 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 blah. And if I press and hold it, it goes and continues to go and prints out that a key was pressed. That's really cool and all, but you guys are probably thinking, well, what good is that if I can't detect what specific key I want? And the way we go and do that is that we also need to go and check out which specific key we're using. Oops. And so we also complement this with the second half by using a variable called key. Key will give you a string. And the important thing I want you guys to pay attention to is that you need to use both key pressed and key for the best results, because key records the last button you just recently pressed. So let me go and show you how to go and do this code properly. If key pressed and the key is G, that means if somebody's holding their finger down on the G button, then this code will run. If they go and release their finger from the G button, it should stop because key pressed is no longer being held. However, the key is G part is still being held down. In fact, I can go and show you guys this. Oops, let me just go and back over here. So if key pressed is true and key equals quote G quote, we could go print a key was pressed. I'm going to go press and revise this statement here. G key was pressed. And you know what? Just on top of that, I'm going to go over here, press enter a couple times. I'm going to just print out draw. And the reason for that is I just want you guys to be able to see the difference of what I'm typing here. So draw, 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 draw. And then I press G, G key was pressed. And that's for as long as I'm holding it down. Holding it down, G key was pressed. Let go, nothing happens. Hold it down, G key was pressed. Let me show you real quick. If I say if key press equals true, if I go and get rid of this line here, get rid of the word and, that means when I run this code, it says draw, 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 draw. Oops, it is really upset with me because it's already having struggles to understand like what is this G thing going on here. So always make sure that you use the key press with the G here. Fantastic. Little details like that to remember, but if you always need some help, just look at this slide and you get a beautiful example to get you started. And so I think here's another one here. If the key is pressed, you guys can ignore those round brackets there. Actually, I do want to just quickly show off here, might as well. I was typing out if key pressed equals true and key equals G. The funny thing is key pressed, it's a Boolean. And you guys remember what Booleans are? Those are going to be either true or false. And the particular nature about that is you're saying if true is equal to true, then do some stuff here. But in Python and a lot of other programming languages, you can simplify to just read just like this, which is a very common pattern to see. It says if this part is true, which is, since it's a Boolean, you guys get to do that right away. If key is pressed and key is G, then run this code here. What if you want to go and detect some other keys? This is the part what our example is. So let's get rid of that. I can go instead put inside of an if statement, another if statement. I could say if key is equal to quote G quote colon, and then I'll take this line here. I'll just cut Control X and I'll paste it here and I'll make sure my indents are proper. And yeah, we can get as many indents deep as we want. I can do lots of if statements. But what I can do over here, I can say if key is equal to V, I can go and print V key was pressed. And now I have the ability to go and detect any key I want with this. So right now, I can press any key I want. Nothing's happening, nothing's happening. I press G, G key was pressed. I press V, V key was pressed. And you get to go and register as many keys as you want with this, which in my opinion, is pretty darn awesome. But if you want to go and show off any particular key here, you can use the text key and you'll just simply go and show that off too. So how about we go and print off one more right in the top here, text, and we'll go key, and then a comma, and then we will go and put that, let's put that in like the center of the screen-ish. And I'll also use text size, capital S on there, and I'll make that 20. And with that, I should be able to go and put some text right in the middle of the screen of, oops, I hope that I'm actually able to show it. Something is not playing nice with me here. All right, I'm gonna have to go and revisit this example here, but I'm pretty darn sure you guys can just simply follow along with this example on the slide here, and it should be able to do the trick as well. I think I might have just got something formatted a little bit funny right now. So it's not the most important part of today, so I'm just gonna skip that over. And I believe one slide here, I'm kind of surprised that didn't show up. Just another key, slide that I want to go and show off real quick. This one might have some struggles here, so I'd say take it with a grain of salt. If you want to do special keys like the Control key, the Alt key, the Shift key, or the arrow keys, you guys are going to need to use key code, capitalize C on that. And yeah, there is some special notes here, so I'm going to ask you guys, take a look at the documentation for now. But don't worry, we're never going to ask you guys to go and memorize any of these key code particulars. Instead, I want to go and talk more about loops now. So remember what a for loop is. A for loop is a really natural way how to go and just say, go through some repetitive code really, really, really quickly. The analogy we had was when you're inside a dentist chair, the dentist checks the first tooth, checks the second tooth, checks the third tooth, checks the fourth tooth, works their way across every single tooth. And we had a shopping list. And in this example here, you can go and say, purchase each item. For each item inside my shopping list, grab the eggs, grab the ham, grab the cheese, grab the onion, which is pretty cool. But now I'm going to go and challenge you guys for a moment here. We're not going to answer this right now, but I want you guys to go and consider, what if I had two lists? Remember, we had talked about just one list, like some ham, cheese, onions, grocery lists, etc. But if I want to go and simultaneously get two lists running, how would I get it so that, for example here, I can have both a list of colors here, so shades of light gray, dark gray, black, etc., lined up with a list of y coordinate positions. If you notice here, they're not all evenly spaced. There's no clean math function. They're all arbitrarily randomly spread out. In fact, what it means is we have two lists, but we need to go and iterate both of them over at the same time. If I have my two lists here, I would want them to somehow line up so I can say the dark gray with the top element, the black with the second element here, light gray with the third spot, the white with the fourth spot here. And we don't have a natural way how to do this yet, but here is one of the solutions that we are going to go and show you today on how to do this. We're going to be doing this with something called range. Range just simply gives you a list of numbers. It's a very, very simple idea here where if I want to get a list of numbers here, I want to be able to do it rather quickly. And I'll keep pressing the wrong button, pardon me. Let me go and show you here. I'm going to just go wipe all of this stuff out. I don't need that. And what I'm going to do here is say, what if I want a list of numbers? List of numbers. And the boring way is to go 0, 1, 2, 3, 4, 5. I'm like, I'm not very patient. I don't really like doing that. And if I want to do this faster, fast numbers, I can instead type out range round bracket 6. And that's all it is. That's basically it. That I used a range function and it gives me pumped out a list of numbers. And we'll see why this is useful in a moment. But I want you guys to go and pay attention to a very, very specific detail here. Tell me, this is a number 6. In the meanwhile, how many numbers did I push into this list right here? How long is this list? Six numbers. Okay, easy peasy. Nobody's getting fooled with that. But I do want you guys to pay attention to some specific details. I started at 0. I did not start at 1. I started at 0. And I stopped at 5. That gives me a total of 6 numbers. When I use the range function, it's going to do the exact same thing. It starts at 0. It stops at 1 number just before the number you put inside here. So it does not stop at 6, it stops at 5. And keeping this in your mind is going to be rather helpful because it's actually a very, very intuitive way to talk about list indexes, if you guys remember. So when we talked about index for our list here, this was 0, 1, 2, 3, 4, 5. It lines up exactly 1 for 1. And that's going to be very, very convenient for us because once I pop back to my slides here, we can go and use this inside of a loop. This is just, after all, a list. So, hey, let's go and print out these numbers. Let's go print out hi 6 times really quickly. What I can do is I can go for I in range of 6 times here, colon. I'm going to go and print hi. And when I run this, we got hi printed out 6 times. 1, 2, 3, 4, 5, 6. If I want an easier way to view this, I can instead go and print out the number, the value I'm printing out here. By the way, why did I use the word I rather than item? It's because I'm allowed to go and just use whatever name I want. And I is a very, very common one for when we're just talking about pure numbers, just like this, especially when they go up in a very simple, easy to understand order. And it's just faster for me to type, short for index. So when I print out I, it gives me out 0, 1, 2, 3, 4, 5. Pay attention, does not print out 6 here. It's going to stop at 5. Let's go and try out something else that's a little bit more interesting with this now. Let's go and print out not just 0, 1, 2, 3, 4, 5. Let's go and print out some specific numbers. So let's say I have the numbers 5, 32, and 26 inside a list of numbers. Let's go and try out the range function with this. For I in range of 3. Let's see what happens. First things first, we're going to go and print out the number inside here. So we're going to go print numbers of I. What is I? I is going to be the first value inside the range, which is going to be 0. And that's going to go and look up here. Numbers of 0, the 0th index is going to be the first number. That's going to be 5. Let's print out 5. Next time round, I is going to go up 1 number. That means I is going to be 1. And when we go numbers of I, that means numbers at the first index. First index of numbers is 32. And so we're going to go and print out 32 there. One more time. We are going to go and up 1 more. I is going to go to the number 2 now. We're going to print numbers at the index of 2. And when we take a look here, numbers 0, 1, 2, that's going to be 26. Perfect. And we're going to go and print out all those numbers here. I'm going to pause right now and ask, does anybody need me to explain this again? All right. I don't see any comments in chat here, so I'm assuming you guys are doing masterfully on this here. So we'll just carry on with this. Okay. And so now the next part here is that we're finally going to go and revisit that question on how do we get looping across 2 lists at the same time? I'm going to go and show you now because we have a way how to start talking about 2 lists simultaneously because they both use the same kind of indexing pattern here. So let's go and say that we got a list of balls on the screen here or circles that we want to draw, and they each have different diameters here. So different sizes that we want to talk about. So let's go and say that the first one, it's positioned 40 pixels to the right. The next one's 100 pixels, and then 180 pixels, and then 260 pixels. And then we're going to talk about some sizes here. We got size of 12, we got size of 33, size of 40, and a size of 8. What I can do now is say for I in range of 4. 0, 1, 2, 3. That is a total of 4 numbers here. We're going to go and try drawing out the ellipse here. So we can go and say ellipse. Take the x coordinate for balls or from the balls list, and that is going to be 40. We're going to take the y coordinate, same number here. That's going to be I is 0, grab 40. And we're going to go and choose the x and the width and the height for this. We're going to look at the sizes. Index 0, that's going to be 12. Next up, when I is going to be equal to 1, that is meaning we're going to take balls of I. That's going to be balls of 1. That's going to be 100 pixels to the right. And we're going to set it to a size of 1. That's going to be 33 on here. Next up, 180, which has a size of 40. Then 260, which has a size of 8. And you have a really cool way to line up multiple tables, sandwich them together. Now I'm going to go and challenge you guys with a quick question here. Let's take a minute, 30 seconds to see if you guys understand how to use this range with multiple lists. Right then.
Okay, I'll close the poll in about 5 seconds. All right, so we have 83% saying option number A, which is 9, and that's the correct answer.
Great job, guys. I think it's too hard to trick you guys on here. Fantastic. You guys all notice it says take the first list item here. That's going to be index of 0, and that's going to grab the value 1 and add it onto our result. 1, add in the second one here. It's going to be 0, so that's total 1. Then you're going to add in 3 and 1 on top of that. So that's 1 plus 4. That's going to equal 5. And then you're going to go 5 plus 2 plus 2, and that's going to give us a total of 9. So fantastic. Nice job, guys. The last thing I want to go and talk about, I touched upon it pretty darn quickly last time, but I think it's pretty important to go and show off the fact that normally we don't actually like putting singular numbers inside of our for loop there. In the case of like Shoot Like Ignite, when you guys are just learning, that's a-okay. But something else that we'd like to do, I have my list of numbers here. Let me just go and show you guys real quickly and make sure my example lines up. So let's get a list of x positions, 20, 100, 5, 60. X pose is equal to 20, 100, 5, and 60. And let's say that's for the 4 circles that we're planning to draw on our screen. Oh, that's pretty good. We can just simply go for I in range of, there's how many items here? 1, 2, 3, 4. Okay, we'll just type in range of 4. And we can go and print out each x position of I. And no surprises, we got all those numbers out. Dandy. But now the thing is, what happens if I go and let's just say, pop in another item here. Let's put it at 200. When I run this code again, 220, 100, 5, 60, and oh no, what happens to our 200? Yeah, I forgot. This range here did not update automatically. It didn't follow along. I'd have to go and change this to 5. Okay, that's not bad. But what happens if we go and start adding some really tricky stuff? Xpose.append 300. Oh shoot, now I have to start counting up more here. Make that 6. Oh no, what happens if I make it so that the user can click? No, I have to go and count how many times they're going to do it. And that's going to be really tricky. And the easy way to get around this is instead of trying to manually count this, so don't manually count the items. Instead, just use the length of the list automatically. And the way we do that here is that instead of using 6 here, let's just use the number n just to represent the length. And I'll go length, len, round bracket, of x positions. And then I can go and plug in n right here. It'll automatically go and fill in the blanks here so that it gets every single item for me. And using length here is a very common pattern to go and get a much more powerful piece of code. We remove what we call the magic number, aka one of those manually plugged in numbers here, and we got the computer to automatically calculate it for us to make sure everything stays nice and tight. And that's the way that we make proper programming happen. Okay, so back to that example now. I think it's finally time. Let's see, just to go and see how we get everything working here. And I think that you guys might have already got a hint on how to do this, but basically we got a list of our shades for those different grays, and we got a Y list coordinate going on. And we use for I in range of, ooh, why are we using that number 4? That should be length of shades here. But either way, just for this simple example, it should work just fine. We're going to go and set the fill to, oh, does that say colors? Oh, yeah, that's a typo on my end here. I'm sorry. That's supposed to say shades, just like that. We'll just ignore that little detail there. So we'll fill the shades to be 100 with the Y position of 50. Then use the next shade of pure black, 0, at the Y position of 220. And we're just going to keep on working our way through this list, which I think gives us a really good opportunity here. What I'd like for you guys to do is try first draw 3 different circles out of here. And you're going to need 2 lists here. One of those lists are going to control the X coordinates. The other list is going to control the Y coordinates here. And then if you guys have some extra time on this for you brilliant programmers out there, can you figure out a way how to make it so that those balls can move based on the arrow keys that you use, or use A to make it move left and D to make it move right? Let's take 15 minutes to try this out. Right. So how did you guys do? How many of you guys were able to get the 3 circles drawn on your screen here? Let's see people answer in chat. Nice, nice. Anyone else able to get the 3 circles drawn? Okay, awesome. Okay. Fantastic. And did anybody able to get the animation working, the bonus challenge here? Were you able to make it respond to your arrow keys? Interesting. Well, that's pretty impressive. That's pretty impressive to see. Well, that's awesome. How do you get those circles moving? I'm going to leave it as a bonus, not going to tell you the answer. But the number one hint I can tell you that I've heard another mentor talking about is if you apply an offset as just a variable to keep track of how much more X or how much less X to be adding on, then you should be able to figure out creatively how to get that working. Anyway, I'm done talking about for loops for now. Instead, I want to go and talk about another type of looping mechanism, another way to get the code to repeat itself. And that's called the while loop. And just like an if statement, the while loop just basically checks if something is true, which feels quite different than the for loop. But fundamentally, I feel it's actually pretty easy to wrap your head around. While loops, or for loops, last time we talked about them, they say that you work your way through a set list. A while loop is different because there is no list that you work through. You just keep on going until there's something that tells you to stop. An analogy to go and tell you about is like if you have food on your plate, you don't count the number of grains of rice that you eat, for example, here. No, what you do, you just start eating and you're just going to keep going. And while you keep on eating, you're just going to keep shoveling food into your face there. And then you're going to finally finish there. And then you're going to exit the while loop and get other stuff done. So you don't know how long it's going to take. You don't know how much there is, but you're just going to keep on doing it anyways. Keep repeating an instruction until you're done. Let me go and show you the syntax on how to do this. So we base a very, very common pattern for this is to say, while a number is lesser than some other number, keep on adding it up and printing it out. So I is set to 0. So that's going to be code before here. And then check this condition. While this I is lesser or sorry, is not equal to 10. Well, 0 is obviously not the same thing as 10. So we're going to go and do this thing inside the body. This is going to be printing I. That's going to be printing out 0. Then change that I out to be plus equals 1. That changes it to 1. Go back up. 1 is not the same thing as 10. That's true. Go inside. Repeat the code. Take a look. 2 is not the same thing as 10. Go inside. Take a look. Repeat the code. 3, etc. And we're going to go 4, 5, 6, all the way up till 9 is not the same thing as 10. Go down inside here. Bump it up. 10 is the same thing as 10, though, which is no longer going to be true. This statement is now false, and we're going to be finished with that. What I want to go and show you, though, is something rather important to pay attention to, is that while loops, they run so incredibly fast that you never want to have a while loop just permanently running because your computer kind of gets stuck inside here. So don't run this code. Do not copy along here. But let me go and show you something. I set it to 0, while I is not equal to 10, print out I. You guys remember how last time I said I plus equals 1 to make it go upwards? What if I didn't bother to do that? What if I got lazy and skipped that step? Now I is going to be 0, and we're going to go back up to here. 0 is not equal to 10. Go back. 0 is not equal to 10. Go back. 0 is not equal to 10. Go back. 0 is not equal to 10. And we're going to be permanently stuck in here. This is something that we call an infinite loop. And funny enough, I was teaching a class like this a couple of years ago. I popped open my computer. I wrote this very same code. And my program completely crashed because it locked up everything. My computer was unable to do anything because it was so busy just checking out whether or not I was not equal to 10. And it was permanently stuck there. So it's rather funny, but you guys do have to be cautious about infinite loops. Sometimes these things do happen, and it's funny, but just don't do them. So I'm going to challenge you guys with a quick question. That code that we commented out, let's go put in a new substitute here. Which one should we use to avoid that infinite loop problem? Try it out. That should be A, B, C, D.
Okay, I'll just end the poll in a couple seconds.
All right.
Okay, so we do
Fantastic.
percent saying A, which I think is the correct option. So
Nice job. I can't trick you with any of these other crazy trick questions here. We used to have this question be a lot harder by making this -10 instead of +10, forcing you guys to think a little bit more. But it's really unnatural to see things like this. You're going to see it be a lot more common to be basically count up until it reaches a certain number. So thank you guys for going along with that. And I just want to go and hint, now that we learned two types of loops here, we got the for loop and we got the while loop. And in my opinion, the for loop is much more common. You'll see that all over the place. And the while loop you only see occasionally. But it is pretty important to just remember. For loop is really good for working through a set list for every item in a list. Whereas a while loop is very good for running while something is true, but you don't really know when that ending is going to be. Either way, they're fantastic for repeating code and you can use them for multiple lists if you're clever. Basically just using numbers on that. And here is one example where we do believe that while loops are particularly useful. Is when you say you don't know where the stopping point is, you say that let's start x at going to be 50 here. And while x is lesser than mouse x, we don't know where mouse x is. That's where the user is going to be instead. And we're going to keep on bumping up the number as it goes until it reaches mouse x here. we're going to see x plus equals 20 to say just keep on adding it up until we go and reach a certain threshold. With that, I am going to go and give it back to you guys here. 12 minutes to go and try this out. This is a while loop exercise, and I want you guys to focus on getting these rectangles to show up underneath here. I don't really care if you get this nice diagonal slope. First, just focus on getting each slice to go down and stop where your mouse is with the y coordinate. Let's try that out. time there. And we are 1 minute behind schedule, but that's okay. We should be able to wrap through this last little piece here super quickly. I hope you guys were able to get it. From what I saw inside the chat rooms here, it sounded like people really were having a strong grasp with this. So nice job, guys. It sounds like you guys are blasting through this. Last topic I want to talk about, just a really cool and easy way how to generate some random numbers. Random numbers are so powerful just because they're there. And the way that we do this here, I'm going to go and in fact show you on my code here. What we want to do with this to get random numbers, let's go over here. You got the from processing import star. You guys know how processing is this external thing that we have to bring into Python? Random is exactly the same deal here. So we're going to go and type in imports random, just like that. And when we want to go and generate a random number now, let me go and wipe out some of this code here that we're not using. I'm going to go and say, I'm just going to use R for my random number variable name. I'm going to say random dot, do it again, random, round bracket here. The reason for this, random is the name of the module, the thing that like holds all the pieces of code that talks about random numbers. And then here is the function itself that actually goes and do this. Why do we need to use the from command in processing? There's actually a good answer for that, is that you could theoretically, if you wanted to, say from random import star. This is also technically a way of doing it instead. The reason that I'm doing from processing import star instead, though, is to go and import the processing namespace and bring in a lot of Python-ish details for you. It is a rather convenient method, I would say. But I personally like to use a mix of it. Really does depend on the timing here. Here, I like to use random, just like this, import random, so that way I don't lose track of where the heck do these names come from. There's a lot of semantic details here. And if you want, you can go and search up Python imports. And it really does, let me see, a tutorial just like this one here would go and give you a little bit more of a guide on what that's about. But for today, that's pretty out of scope, so you don't need to worry about that. That's just optional reading for you guys. If you want a random number, though, that is part of something I want to talk about. We can go print this random dot random round bracket, and we just go and print my random number here. And if we see, we're getting a whole bunch of random numbers. All of them are between 0 and 1, which is pretty darn convenient. If you want to go and get a random number between 0 and 100, there's a very simple way how to do that. You just simply say R is random.random multiplied by 100 here. And now all your random numbers span from 0 to 100. And there you go. So you got easy control to get random numbers from any range you want. Let's say you don't really like those decimal places though. There's another easy way how to do this. So I'm going to go use another very poorly named variable. Let's comment out this code just so I don't have to show this. I'm going to use I for my random integer is set to random dot integer is shorthand is called int. So we're just going to say ran int, open round bracket, close round bracket. Oops, sorry. And I need to go and specify what's the lowest random number I want and the highest random number I want. Let's go and say I want a random integer between 3 and 9. And then I can go and print my number I. And with this, you got a whole bunch of random numbers printing. And what's pretty cool, I've seen people go and make this so that you can have automatic dice rolling features on your system. And honestly, I found that to be pretty cool. And friends of mine have worked on like Dungeons and Dragons bots that can go and build up these dice rolling features just for you. So it's pretty cool stuff to be able to just get random numbers on the fly. Plus, when you're generating video games, a very common pattern is that you randomly spatter some enemies across the screen. Random variables helps a lot with that. Anyway, random numbers are convenient. And here's another one using visualization. You say the diameter is set to a random integer between 25 and 75, and you can get a whole bunch of different smattering of circle sizes. I'm going to leave it to your creativity to figure out other ways you can use random. But with that, I'd like to go and challenge you guys to try out a couple bug buster exercises here. This rippling pond one, I think, is a really fascinating one to stare at. So I'd be excited to see you guys make that one. And of course, I think that you guys are becoming masters of this stuff here. Here's an application of that random number one, just for fun challenge for you guys. Let me know if you guys do get this one, because that'd be exciting to see. And of course, even more here. Here's a colorful variation of that as well in a physics simulator. All right, enough of me talking. Let's wrap up here. and we'll go until 7:28. I'll get rolling. So nice job on the exercises. I saw some people are plowing through them already quite ahead. So that's amazing. What I wanted to go and quickly tell you guys, I've told some groups already, but for those of you who've not heard it yet, is that the final project is coming up in a few weeks. And that's where you guys get to go and build your own game using processing and all the stuff that you've been learning here. And you guys have the ability to basically create anything you want, and we'll have some dedicated time for it. I will be giving more instructions about this later on, so don't worry about it right now. But I'll just leave that little nugget in your brain. It's like, just start imagining the things that you guys can build. With that being said, though, I'm going to go and close it off by asking you guys just a regular end of the session poll here. And when you guys finish that poll, you guys can get out of here.